Welcome back to Flightpath Pioneers, helicopter lesson in 15 minutes. We continue on the path of basic aerodynamics. We talked about the airfoil, angle of attack, and things like that in the previous session. We're going to continue to build upon that at this point in time. Again, of course, we talk about the air components of the main rotor and the tail rotor. Again, on the end of the day, all comes down to this, right? We want to be able to go places, therefore we need to generate lift. And sometimes when you look at helicopters, and especially when you look at a downwash, the violence associated, we are beating the air up in order to be able to take lift. Well, there is some part of truth to that, right? But let's dive a little deeper to understand on how that actually works. Well, first thing we need to understand, in order to generate lift, right? We talked about changing the angle of the blade, right, by raising the collective. But to do that and to actually lift off, we have to overcome weight, right? The gravitational forces of the weight of the aircraft and all of its components and people who are inside of it. Of course, once we want to go forward, we want to overcome, thrust needs to overcome drag. So these are the four forces that you'll need to take into account in everything that you do. And of course, it starts with a good pre-flight. It starts with making sure that you do a weight and balance on your aircraft itself to make sure that your center of gravity is in the right spot, right, within the safety envelope. Now, as you continue flight for the hour or two, because that will shift a little bit because of fuel changes, but also the total weight that you have to make sure you don't, stress out. And the third component of the course is, of course, the weather conditions out there that need to be in temperature, hot, cold, humidity, high, low. Are there any other elevation differences, things you need to take into account? All of these, you have performance charts in your pilot operating handbook that you should learn to look at, and we'll talk a little bit more about that as we're going to continue to go on in the more advanced portion of aerodynamics and flight characteristics. So again, here basics, right? So lift is very simple. The vertical force due to upward air passing around the airfoil, acting perpendicular to the flight path through the center of lift, and it directly opposes weight, right? Lift, we want to go up, but we're always being pulled down. In order to overcome that, we need to create more lift to overcome the pull. The pull of the aircraft, therefore, on weight is downwards, right? Towards the ground. Gravity, right? That we all have to live with that. So it's the combined load of the aircraft and all of its weight inside the aircraft, right? It acts vertically, straight downward, through the aircraft's center of gravity, and it opposes lift, right? If we want to fly, we have to overcome this particular piece of the puzzle. Thrust, right, the force that propels aircraft through the air, produced by the power plant and the rotor, right, and it opposes drag. And of course, drag is the direct opposite of that, is the rearward force created by disruption of airflow around the rotor blades, fuselage, and protruding objects, and acts parallel to the relative of the wind, and vectoring backwards. Therefore, it opposes thrust itself, I should say. My Dutch accent gets into the way here. All right, so we're going to talk about Mr. Newton over here, right? So Newton's third law comes into play. It says for every action there is an equal and opposite direction. So the same way that the birds fly, right? With pitch in the blade, the air hits the bottom of the airfoil and then is deflected downwards. Equal and opposite force pushed up as well. So that's a very simple way of looking at it. And again, I say if you look at the two streams of blue, right, going over top and underneath the airfoil, think about this a marching, platoon of soldiers, and they all have to stay together. Well, those traveling on the bottom don't have to travel as far as the ones on the top. So the people going on top need to go faster in order to catch up on the back end. To do that, you start creating a pressure differential. Of course, you also have the angle of attack in a way that when the wind hits it is automatically deflected. So that helps with lift. But lift comes from two components that we need to learn about. It's both deflection, but also the pressure differentials. And with that, we need to think about the Venturi effect. So the best way to do that is think about when you have a hose in your hand. When it's open, right, it just flows. When you pinch it, it actually starts speeding up, right? You can spray the water further. But that same principle goes into play when you're talking about a wing, right? Creating lift. And therefore you have Bernoulli's principle that as the velocity increases, the Venturi effect, that the pressure decreases, right? So the overtop increases, right? So the pressure decreases. So it's low pressure. So you have high on the bottom, low on top. That helps create that lift. Again, I would recommend you to go online and look at for YouTube clips. You can see these things by actually, they use smoke or rain or kind of like particle conditions in it, maybe in a test chamber, to actually be able to visualize this. So I recommend you to take a look at that because it really helps you understand. Now, remember we talked about that critical angle of attack. This is all good until you reach the critical angle of attack where you have this delamination of the air going over the top of it, which then becomes disturbing, which then has the direct opposite effect. So you're actually losing lift rather than generating lift, right? The only way to correct that is by lowering the collective as quickly as possible. So you can make that back, and of course slowing down also helps. So the four forces here, how we look at it, is that you look at the pictures A, B, and C, right? It is the angle of the attack, so that short line. And this is an asymmetrical chamber that you can see because it's flat on the bottom and more rounded over the top itself. And the different pictures, as they increase the angle of attack, you can see how there could be disturbance taking place, right? You meet that critical angle of attack. And all these things can come into a calculation that you have to learn about for your test. Nobody's going to ask you for this in the air, of course, is the lift equation. So let's break that down a little bit more into the individual components. So the coefficient of lift that can be changed by you, right, measures the ability of the object to create lift, determines the shape of the airfoil, which is, of course, you cannot change that, because that is fixed, but the angle of attack you can change, right? The coefficient of lift is essentially the angle of the attack itself. The angle of attack increases, the amount of generated lift increases up to the critical angle of attack, which we have talked about a couple of times now, right? There is a maximum of that angle of attack, resulting in a maximum lift beyond which the lift drops off dramatically, right, and creating a stall condition. And this is something that you have to be very, very mindful about when flying. Right? That's how you can fall out of the sky, so to speak. So half of the air density, right, is not changed by the pilot. That's an outside condition, right? The air density is changed by altitude, temperature, moisture, and humidity. None that you can control, but you should take into calculation before you take flight. So the more dense air, the more molecules the blades push against to create lift. Right? The air density represents the mass of the air being encountered by the airfoil. Because of Newton's third law, the more air mass we can deflect downward with the airfoil, the more airship mass we can lift into the air. So the hotter it is, the farther spread these molecules are, that becomes problematic over time, right? So on cold days, it's easier to fly because it is more dense. And of course, altitude changes that as well, not just temperature, right? Air is thinner as we go, so the molecules are further apart. All right, the speed is the movement through the air itself, right? It represents the true airspeed. And it's a significant element of lift equation because it is squared, right? It's a small change of velocity results in a large change in lift. So that's one thing that you will learn is that if you are at max capacity or high altitude, or you have certain conditions, you might want to have a running start, right? So in other words, we have to have an air space in front of us that we want to start moving forward. And for every every nautical mile going forward, that velocity is squared. That helps create lift itself. Again, that is one way of doing that. Again, now you're really pushing the envelope if you are so heavy, or the air is so thin that you want to have a running start. But of course, as you fly, and you burn off fuel, so less weight, that should be. But it's for the same reason as you come back in, you might have to have a run-on landing to be safe. So again, space becomes of the essence at that point in time. So speed, V, is affected by the helicopter movement, but the effect is small except at higher speeds, right? So S is for surface area, represents the surface area of the airfoil itself. This implies that the larger the surface area, the more lift that can be produced, right? The surface area of the airfoil on the helicopter is fixed. Our blades are what they are. We can't make them any bigger than they are, right? They're designed for the particular. So generally thought to be unchanged and unaffected by the pilot. However, the blade coning affects surface area and can be influenced by the pilot, allowing low rotor RPM, high gross weights, and high G-forces. So that's something, again, I would recommend you go to a YouTube clip. You can actually see this, the coning of the blades that take place, right? And we have seen too that if it is too great, that can cause an aircraft to fail as well. More about that in the next session. All right, I hope you enjoyed this and you took something away. Again, seeing, doing, touching, feeling, and make sure you look at more YouTube clips where you have some really great ways of seeing how this all works. I'll see you in the next session.